Hi everyone, this is Mrs. McCrary. Today we're going to be talking about Book 5 of Euclid's Elements, and in some ways this is almost one of the more confusing books because, well, one, there's a lot of new vocabulary. Euclid has 18 new definitions, which a lot of them are very similar. We've got definition 1, which is actually the definition of the word part. That's the important word there. A magnitude is a part of a magnitude. The less of the greater when it measures the greater. Okay, so the language in this particular book is not real clear. So you do have to be careful when you're reading it to make sure, for example, in Proposition 11, the ratios which are the same with the same ratio are also the same with the other, or with one another. Yeah, I used the phrase the same 3 times, and it means 2 different things in that one, and it means other things in other ones. So there's a lot of verbiage that is very easy to get confused when you're looking at this. But one way it helps if you think about it is if you think about these in numbers. If you assign numbers to the lines, things start to get a lot simpler, or at least a lot more familiar. The concepts themselves still make the same amount of sense. It's not that it's easier if you use numbers, it's just that we're more familiar with numbers, so when something is presented in numbers, that's how we're used to thinking about it, and when something is presented as a random line segment, that's confusing to us because that's not how our brains have been trained to think. All right, so let's look at a couple of the propositions, and I'll show you how if you find numbers that fit these propositions, it starts to make a lot more sense, again, because we've been trained to think in numbers and not in lines, just like right now I am recording this video to you in English, not in Latin, even though Latin is really good for lots of things, and I'm sure we can all have a very long, rich discussion about how wonderful Latin is. None of us grew up with Latin, and so we don't converse in it very well. Likewise, in 2017, we have not been raised in a culture that grew up with lines and shapes. We've been raised in a culture that grew up with numbers. So when we put numbers with things, when we start translating things from Latin into English, it becomes a lot more clear. All right, let's look at Proposition 10. So Proposition 10 says, of magnitudes which have a ratio to the same, that which has a greater ratio is greater, and that to which the same has a greater ratio is less. All right, again, so kind of weird. But let's say, again, we've got line A, B, and C, and these are roughly accurate drawings. Okay, so here we have A, B, and C, and it says for let A have to C a greater ratio than B has to C. Therefore, A is greater than B. We can also say, well, yeah, but I can see that A is greater than B because, look, A is greater than B. I can tell. But then, here's that key question of geometry again. How do you know? How can you prove it? How can you convince me? Maybe you have a bad drawing. Maybe I can see, around a quarter and see that B continues. Maybe you just didn't draw all of B. Prove to me that A is actually longer than B. Because, again, that's what geometry is about. Geometry is not about shapes and angles and lines, and once you are done with this class, you will probably go the rest of your life without having to prove equilateral prove congruent triangles to anyone. But you will have to explain things to people, and you will have to support your reasoning. So again, that's why we study geometry, so that we can see how Euclid explains these concepts. He uses math as the way to do it for a variety of reasons that we can discuss later. But especially now, hopefully that you're reading bigger chunks of Euclid at a time, you can start to see how his reasoning is coming through instead of focusing exactly on how to use a proposition. But anyway, getting back to Proposition 10. So what Euclid is saying is that, for example, let's say A is 4/3 the length of C. So, it's one, it's 130% the length of C. So if C is 1, A is 1.3. Okay? So A is 4/3 of C. C, likewise, is 4/3 of B, so therefore A is larger than B. All right? That's what Euclid is saying. That's what all of that means. And now you can see that once I put some numbers with it, it became hopefully a lot more obvious, right? If A is larger than C and C is larger than B, then A is larger than B. Euclid doesn't say A, B, and C because, again, he's trying to make it general so that it will apply to any lines, and people won't be confused when they come up with lines that are suddenly H, J, and Z. Well, does Proposition 10 from Book 5 that was about lines A, B, and C, does that still apply here, or is this a different situation because these lines have different names? All right, remember, Euclid is making everything generalized so you can use it in any situation. He wants these to be flexible enough that they can be used in a variety of situations. So he's using these kinds of words like the same, greater. The same in this case in Proposition 10 is just what we're comparing both of our lines to. We compared A to C, we compared B to C, so C is the same between both of those comparisons. Let's also look at Proposition 19. Okay? Proposition 19 says, if as a whole is to a whole, so is a part subtracted to a part subtracted, the remainder will also be to the remainder as whole to whole. Again, if you're like me, the first time I read that, that sounded really weird. But let's look at it this way. We have AB. AB is 9 units long. We have CD. CD is 6 units long. Okay? So we can clearly see that CD is 2/3 the length of AB. If we take from CD a section CF, that is 2 units long, and we take from AB AE, which is 3 units long, ACF is still, again, 2/3 of AE, and then that means since CD was 2/3 of AB, and CF was 2/3 of AE, therefore DF is 2/3 of EB. All right? That's what Proposition 19 is saying. So if you're getting confused by these, again, you're reading these to see how Euclid is creating and supporting his arguments, but the math is also good. If you're reading these and you're really getting confused, you can see if you can figure out numbers that will work for these. Obviously, this ratio is going to work for any set of numbers if, say CD was 7 units and AB was 9 units. That's still a specific ratio. It's a harder ratio to, duplicate over here in a smaller way that's easy to understand, but it's still a ratio and it will still lead to the same result. But yeah, if you're having trouble understanding Book 5, see if you can find some numbers that will fulfill the proposition. All of this, all of Book 5, I'm not going to say necessarily was written in order to provide a background for Book 6, but as a teacher, someone who teaches people things, Book 5 definitely seems like background knowledge. It's like you need to know these things about how lines relate to each other before we can start with Book 6 and talk about how these shapes relate to each other. Because once we get into Book 6, we're starting about similar figures, figures that angles are the same, but the lines aren't necessarily. So we start to talk about things like, okay, so this is one oh, that's an isosceles triangle. All equilateral triangles are similar because all equilateral triangles have 60-degree angles. They have things that are in common, but not all equilateral triangles are equal. They're not all the same size, but they have similarities. That's what we're going to start talking about in book 6. All right, and to be able to understand that, we need to understand how lines and line segments relate to each other.